Hey everyone, so I'm going to do a video on your first review sheet for your first test of the quarter. So for the first question, it asks you to add or subtract the polynomials. The first one is just a simple add like term scenario. So what you want to do is find your like terms, and that's what you do to find them is to find the highest exponents first, and the same letter and the same exponent. So the first one I see is the 2h squareds. So they will combine to a 4h squared. And then the next like terms I see are the negative 7h, the negative h, the 4h, and the negative 9h. Combining those coefficients, you'll get negative 13h. And then the final things I can combine, well, nothing combines anymore, is 6, so I'll just add that to the end. So the next question says subtract 6x squared minus 4x plus 11 from 4x squared minus 8x plus 3. When you see the word from, it just means to switch them. So I'm going to do the first polynomial second. So I'm going to write 4x squared minus 8x plus 3 first, and then I'll put 6x squared minus 4x plus 11 second. What I have to make sure I do is put that polynomial in parentheses and then distribute the negative, changing all the signs on the inside of the parentheses. So now I'm going to drop down the first polynomial, and now I can combine my like terms. So like the 4x squared and the negative 6x squared will get you a negative 2x squared. The 8x, negative 8x, and the positive 4x will get you a negative 4x. And then the plus 3 and the minus 11 will get you a negative 8. And this is your answer right here. Alright, next question requires you to multiply polynomials. It's really up to you on how you would like to multiply these things. You could choose to use the FOIL method, or you can choose to use the box method. I'm going to use the box method for this one. With the box method, put the first polynomial on one side and the second polynomial on the top. Now, you can choose which one goes on which side, it doesn't really matter, but just make sure you're setting it up correctly. Alright, so the first thing you're going to do is multiply these two guys, and you'll end up getting 3x squared. Okay, and then the second ones you're going to multiply are these two, 3x and 5y. So 3x and 5y get you 15xy, and then you'll get a negative xy here, and a negative 5x, we'll have negative 5y squared there. And now you just want to combine like terms. These diagonals are like, so they will combine and add to a positive 14xy, because really this is a negative 1 on the outside, so 15 minus 1 gets you 14, minus 5y squared. And there's your answer for that one. Now the next one again is multiplying polynomials, just a larger set, so x and 5 will go on the side here, and x squared minus 6x and positive 3 will go up here. Okay, your first box will get you x cubed, then you'll get negative 6x squared, 3x, 5x squared, negative 30x, and 15. So again, all I'm doing is multiplying this times this, and that ended up getting me 15. And you're basically just keep on filling in the boxes by doing this method of meeting the box from the left and the top. Alright, now again you're going to combine like terms. The first term, x cubed, has nothing that's the same, so he's done. The diagonal here is like, so I get negative x squared. This diagonal is like as well, get negative 27x, and positive 15 does not match anyone, so he stays the same. Okay, so for these problems we're going to factor completely. The first problem, you're going to want to think of GCF first. There's no GCF to pull out, meaning there's no greatest common factor between this piece and this piece. So you have to go to your next factoring, next piece of factoring knowledge. So you have to think, what can I do to this polynomial to factor it, to break it up into two things that multiply back to it. And when I look at this, I notice that it's subtraction, and I also notice that 16 is perfect, x squared is perfect, 49 is perfect, and 8 to the 4th is perfect. Now because that's the case, I can actually break them up using dots, which is the difference of two squares. Difference meaning that there's a subtraction here, and two squares, because this whole piece is a perfect square and that whole piece is a perfect square. So I end up getting 4x and 4x because that's how you break up 16 into 4 and 4 and x squared into x and x. You always do plus and minus. 49 will break up into 7 and 7, and that a to the fourth will break up into a squared and a squared. Now, if you're not sure if you did it correctly, you can always multiply these polynomials with FOIL or the box method, but this is how you do factor them. Now, the next one is also dots. The reason why I know that is because difference of two squares. That's subtraction. There are two pieces, and they're both perfect squares because j to the fourth and j to the fourth, they are letters, and any even power is considered a perfect square when you have a variable. So I'm going to break this up very similarly to how I broke the other one up. I'm going to want to break up j to the fourth as j squared and j squared, plus and minus, and then g to the fourth will be g squared and g squared. Now you have to also notice when you're done with factoring, when you think you're done, ask yourself, can I factor this more? And in this case you can because this is unfactorable. You can't do that anymore with that. But this piece here is dots again. And again, the reason why I know is because it's difference, subtraction of two squares, both squared. They're both perfect squares. I'm going to rewrite this one because I can't factor that anymore. But the second one I can break up into two sets of parentheses. J squared will be j and j, plus, minus, and g and g. So that's how you factor that. The next one, I'm going to first think, okay, is there a GCF? And there is. There's a GCF in all three things. The GCF is 2x. Now, some people, they need to write this underneath so that they can see how it cancels out, meaning that I get no 2's there, and then this becomes a squared, and this x goes away, so it's x squared. This cancels, this becomes a 4, and this cancels, this becomes just an x. So I get minus 4x, and then this cancels with that to get you a 15. I'm sorry, a 45. That was silly. And then the x's will cancel, so I end up getting minus 45. So this is how you pull out the GCF. The next step you guys will not have on your test, but because it says factor completely, I'm going to. It's a trinomial, so the way that you factor this is x and x. This is a negative, so different signs, and we want to add to a negative 4, so that'll be a minus 9 and a positive 5. But GCF is on your test, so you should know this part. Write a function that moves the original function y equals f of x 5 units to the right and 6 units up. You should know that the right is on the inside, and when it moves to the right, you're going to have a negative, and when you go up, it has a positive. So this original function will change to x minus 5 plus 6. Remember, right or left is on the inside of the parentheses, and up or down is on the outside. Right or left, negative means right, positive means left, and plus means up, and negative means down. Okay, so for this problem it says given j of x equals 3x squared minus 2x plus 1 and kx equals x squared minus 3, they want you to express jx times kx minus the sum of kx plus jx as a polynomial in standard form. Now standard form means our final answer needs to be from the high exponent to the lowest exponent. There are several steps in this problem, but if you just take it piece by piece, it should be fine. So what I'm going to do is first write what they want me to write. So j would be 3x squared minus 2x plus 1. Put that in parentheses, going to multiply it by k, which is x squared minus 3. Minus, this bracket is just to separate the two different operations that are happening, which is addition and multiplication, and then the subtraction in between. So I'm going to add j of x. Now the first thing I'm going to do is probably the sum, which is inside the bracket, just because it's simpler. So like I can add the x squared together to 4x squared. The 2x isn't add with anything, so it'll come by itself. And then minus 3 and plus 1 to get you negative 2. Alright, so now the bigger part is going to be the multiplication, which the best way to do this would be using the box method, because it's a trinomial and a binomial. You're more than welcome to use FOIL, but I think it's easier just to do the box because you can see everything. So it'll be 3x to the fourth. Remember, you're multiplying the coefficients and adding the exponents. Minus 2x cubed. And then x squared goes here. Negative 9x squared. And then 6x, and then negative 3. Okay, so now I'm going to put that right next to my blue, combining any like terms. So 3x to the fourth won't combine with anything. Negative 2x cubed won't, but the 9x and the x squared can combine to a negative 8x squared. And then plus 6x minus 3. Now the one thing I didn't remember to do over here is I forgot to put the bracket around this, which is very important because I do have to distribute this negative into here in order to properly combine like terms. So this will be minus 4x squared plus 2x plus 2. And what I'm going to do is I'm going to combine those with what I have here from my multiplication. So what I can combine, well, remember standard form, so I'm going to put 3x to the fourth first. There's no x cubed on this side, so I'm going to write the x cubed right next to the 3x to the fourth. But the negative 8x squared, that's here, and the negative 4x squared, that's there, can combine to a negative 12x squared. The 6x and the 2x can combine to an 8x. And then the negative 3 and the 2 can combine to a negative 1. And this is your answer. This question says the profit function P of x for a company is the cost function C of x subtracted from the revenue function. So first off, I know P of x is equal to the cost subtracted from the revenue. So it would be R of x minus C of x. Now they say the profit function for Disney Corporation is this right here, and the revenue function is this one right here. They want the cost function for the Disney Corporation. So the first thing I'm going to do is solve for C for the formula I just wrote, and the easiest thing to do would be to add C of x over, just because it'll keep it positive to deal with. So it'll be P of x plus C of x equals R of x. And to get C alone, now all I have to do is subtract the P of x. So I have C of x is equal to R of x minus P of x. So all I have to do is do the revenue minus the profit, and I get my answer. So my revenue function is at the top. So I have C of x is equal to my revenue, which is negative 3.5 x squared minus 75, minus again with the parentheses, because you're subtracting the whole function, 2.4 x squared plus 65x, and then minus the 400. And I'm going to distribute this negative in, because I'm subtracting the whole polynomial. It'd be negative 2.4 x squared minus 65x plus 400. And now I can add my like terms between this and this. So my negative 3.5 x squared and my negative 2.4 x squared will give me a combination of negative 5.9 x squared. And again, I'm going to put that in the front because it's the highest exponent. And then I'll have the negative 65 is all by itself because it only is the only x value. But this negative 75 and the 400 will add to a positive 325. I'm going to label this my C of x. So C of x equals this. Alright, the last question asks you about a function that is graphed, and it asks you a few questions about that function. Now the first question says, state the parent function that would look like this graph. Well, the parent function that looks best like this graph is the absolute value of x, which looks like a v. And this is absolutely a v graph. So we're going to state our parent function as y equals the absolute value of x. Now the next question asks, write the equation of the given graph. Well, this graph was transformed, this graph right here. And the original function was moved left 1 and up 2. And it was also reflected over the x-axis. So to write this, you're going to have y equals negative absolute value of x, negative for the reflection, plus 1 for the moving of left 1, and up 2, so plus 2. The next question says, what is the domain? Domain are your x values, and it is really asking you, what values does this graph exist for x? Well, the graph completely extends this way and keeps going, and it completely extends this way as well. So basically, when you're on the x-axis, will you always have a point? And the answer is yes, because you'll have a point up here for those. Then it'll change to down here for the lower negative values, and you'll keep getting values in either direction. Again, up you'll have a value, and down you'll have a value. So this answer would be all real numbers. The next question says, what's the range? The range is the y values. And again, look at your y-axis and say, do I have a value? Well, if I look at my y-axis and I'm on it, I would hit values here. I would keep hitting values here. But once I got here, I would really stop because there's nothing up here for me to hit. So the range for this graph is y is less than or equal to 2, because all the values that work are those that are 2 and below. The last question says, describe the end behavior. And again, that's as x goes to infinity, what happens to y? And as x goes to negative infinity, what happens to y? So you're going to look at your graph and say to yourself, okay, what's happening in these two cases? Well, as x goes to infinity is the first half. What happens to y? Well, the graph itself goes down to negative infinity. So we're going to say y goes to negative infinity. And the same thing for the next graph, well, the other side of the graph. As x goes to negative infinity, what happens to y? It still goes down to negative infinity. So this is your end behavior. All right, I hope this helped. I'll see you guys tomorrow, and good luck. So for the next one, it says f of x is graphed to the right on the same set of axes, graph f of x plus 2 minus 3. This is very simple. They just want you to move f left 2 and up down 3. The reason why I know this is because this is inside the parentheses of the function. This is outside the parentheses of the function. You cannot put this into your y equals because there are two variables here, f and x. But what you can do is take f of x, which is right here, this weird shape, and do what they're asking, which is moving it, and that's actually the next question, left 2 and down 3. So you're going to take every single point and go left 2, down 3, left 2, down 3, left 2, down 3, left 2, down 3. So I'm going to take my first point, I'm going to go left 2, down 3. Then I'll take my next point, left 2, down 3. Next one, left 2, down 3. The next one, left 2, down 3. And here's your graph. Just make sure it connected just like they connected it. And that's it. So good luck, study up, and I'll see you guys tomorrow. This question says state the end behavior of the given function. So I'm going to look at my graph. As I go to the right, it goes down, so that's negative infinity. As I go to the left, which is negative infinity, it goes up. So I'm going to write as x goes to infinity, which means the right, y goes down. And as x goes to negative infinity, which means the left, y goes up, which is positive infinity. The next question says prove that a squared plus b squared squared equals a squared minus b squared squared plus 2ab all squared. So the first thing you want to do to prove this is you're going to want to multiply out the left side. Then we'll multiply the right side out when we're done. So I'm going to write this out twice because there's a plus sign in between. So you're going to want to multiply it out using FOIL or box method. So when I multiply this, I get a squared times a squared, which is a to the fourth. A squared times b squared is a squared b squared. Again, a squared b squared here, and b to the fourth here. I can combine the middle two terms because they're both a squared b squared, so I'll get a to the fourth plus 2 a squared b squared plus b to the fourth. And this is it for my left side. But I'm going to now have to expand the right side to see if this actually can be proven. So I'm going to first expand this out. So a squared minus b squared and a squared minus b squared. And then I can actually just distribute this in because there's no plus sign or minus sign. So it becomes 4a squared b squared. But this guy I'm going to have to do box method like I did before on the other side. Don't forget your negative. So if I have a squared times a squared, I get a to the fourth. A squared times negative b squared is negative a squared b squared. Same thing here, negative a squared b squared. And I get b to the fourth here. Again, just like the left side, the diagonal is like terms. So I have a to the fourth minus 2a squared b squareds plus b to the fourth. And I cannot forget about this guy. He was up there, 4a squared b squared. These guys are like terms 1, 2. So I can combine those by doing negative 2 plus 4, which is positive 2a squared b squared plus b to the fourth. And since this side is equivalent to that side, it has been proven. Study, good luck, and I'll see you guys soon.